Salam and welcome everyone. So today we're going to be working on the question on the screen that says use Troughton's rule to predict the enthalpy of vaporization of benzene from its normal boiling point, comma 80.10 degrees. So they're trying to tell us that the boiling point of this particular question is the boiling point of benzene in this particular question is 80.10 Celsius. So yeah, 80.10 Celsius. So in order for us to go, of course, from 80.10 degrees Celsius to Kelvin, we just have to add it. So that would be 273.15 plus 80.10 degrees Celsius. So you just add them up, you end up with 353 point, yeah, 353.25 kelvins. So this temperature, and whenever you're dealing with Trojan's rule, is just going to be TB. So the boiling point temperature. So that is it. Now to write out our second parameter, we're not giving a second parameter, but in order for you to know what to do next, you have to know the formula for Trojan's rule. Trojan rule is just basically the change in vaporization enthalpy, or the change in standard enthalpy of vaporization, okay, is equal to the boiling point times, or the boiling point temperature times the change in standard entropy of vaporization. So that's going to be this right here. So this is basically what it is. And we're asked in our question to find the enthalpy of vaporization of benzene. So what we're actually looking for right here is this one that I'm writing. So this is it, the change in enthalpy of vaporization, or standard enthalpy of vaporization. So this is what we're looking for. We're already be given this information here. But of course, we know anytime we're given one unknown and you have three different parameters, you have to make sure the two are known in order for you to solve for the third unknown. Well, we also know that since we're dealing with chemistry, we can always go to the resource section of our physical chemistry textbook to find the change in entropy of vaporization for the particular molecule we're dealing with, and we're dealing with benzene. And when I went to check it, I ended up finding the change in entropy of vaporization for benzene is actually 87.2 joule per mole Kelvin. So that's just basically how it's done. So of course you have two parameters, so you can just simply substitute. So you have the change in enthalpy of vaporization is going to equal 353.25 kelvins, okay, times the change in entropy of vaporization would be 87.2 joule per mole Kelvin. So you cancel out kelvins. So the change in enthalpy of vaporization is now going to be 353.25 times 87.2 joule per Kelvin. So that's going to actually give you 30,803.4 kilojoule, 80.4 joule per mole. So joule per mole. So you may be looking at this question, and many times whenever you're dealing with enthalpy, you're always getting the answer either in joule per mole or kilojoules per mole, but majority of the time it's in kilojoules per mole. And if you look at this question, you can see how large the value is. So what I'm going to do now is to go from joule per mole to kilojoule per mole. But before we do that, let us remember that we're going to be putting our answer in a number of significant figures that of the question that we're given. So when we see the question, we see that um, our normal boiling point is in 3 sig figs. Our change in entropy of vaporization for benzene is also in 3 sig figs. So we have to make sure our work is in 3 sig figs. So what that would mean is the change in enthalpy of vaporization is now going to be 30.8. Then since we're dealing with kilojoule, that's going to be 30.8 kilojoule per mole. And of course, how you do this is when you're trying to go from joules to kilojoules, okay, you're just going to divide, right, by 1000. So that's basically what I did here. I just divided by 1000, 30,803.4. When you divide it by 1000, you just have 30.8034. And of course, since we're doing it in 3 sig figs, we end up with 30.8 kilojoule per mole. So this is basically the answer to this question. If you have any questions, please put it in the comment section. I'm going to try my best to answer them. If you have any concerns or suggestions, please put it in the comment section. If you're a student who is trying to succeed in all your STEM related courses, make sure you email me at shohabitutoring@gmail.com in order for you to see the services I render. I help students who are trying to be the best version of themselves while taking STEM related courses in school to succeed. So if you're a student looking to succeed, email me at shohabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.